In this video, we're going to focus on solving two-step equations. And these equations are just as they sound. It's going to take 2 steps to solve them. And there are actually 4 different types of two-step equations, and we're going to focus on types 1 and 2 in this particular video. So before we begin to solve equations, we need to know what we are actually doing when we solve two-step equations or multiple-step equations or however many step equations we're looking at. When we are solving equations, we are essentially undoing the order of operations backwards. So we're going to use our knowledge of the order of operations, and we're going to undo the order of operations happening to x, or whichever variable we have, backwards. So on the screen, you can see the first 2 types of two-step equations we're going to focus on today. And I want to highlight a couple of big differences between them. So what you're hopefully noticing is that these 2 actually contain the same types of operations. We can see that we have multiplication taking place between this 5 and this x. And we can see that we have multiplication taking place here between the 5 and the parenthesis. We can also see that we have a plus 10 going on in each problem. But the important thing that we need to note, the differences that we need to note between these 2, is that this one contains parentheses and this one does not. So we're going to be talking through how we would solve these 2 types of equations, how they're different, and how we solve them because they are different. So notice parenthesis here, no parenthesis here, but both of these 2 equations utilize multiplication and addition. So for each problem that we solve, what we're going to do is we're going to look at the equation and we're going to focus on the side with x. So here I can see the side with x, and temporarily I'm going to forget that this 37 is there. It's not disappearing from the problem, but we're going to ignore it for right now, and we're going to just focus on the side of the equation that contains the x value. And what we want to do here is we want to look at what operations we see. And what I notice is I have a multiplication and I have an addition. So what I'm going to do is I'm going to write out the order of operations between multiplication and addition for this example that I see here. So I need to know my PEMDAS, I need to know my order of operations, and if I focus on my PEMDAS, I notice that this multiplication here, this multiplication of 5, is going to come first in the order of operations, and then this plus 7 is going to come second. So we always start off by listing off our order of operations. In the order of operations, multiplication is first and addition is second. And when I solve an equation, what I'm doing is I'm undoing these operations backwards. I'm undoing them backwards. So I'm going to write my equation again right here. So I have 5x plus 7 is equal to 37. And I'm going to undo the order of operations in reverse. So I'm going to start here with the second one. And I'm going to say, okay, so I added 7, or I have a positive 7. The way to undo that is to subtract 7 from each side. So here I have 7 minus 7. That becomes 0, and I have 37 minus 7, and that becomes 30. So here what I'm left with, after I subtract 7 from each side, is 5x is equal to 30. So I undid this order of operations step, and now I'm going to move up, and I'm looking at the multiplication of 5. Well, to undo a multiplication of 5, I need to divide both sides by 5. So that's what I'm going to do here. I'm going to divide both sides by 5. You can see that there. Well, 5 divided by 5 is just 1. So I'm left with just a 1x, or an x, on the left-hand side. And 30 divided by 5 is 6. So by listing out my order of operations and undoing them backwards, I'm able to find the value for x, where if I put this value for x back into my original equation, here I would have 5 times 6 plus 7 equals 37. Well, 5 plus 6 is 30. So I've found the one value in this equation that will make this equation true. So I found that x equals 6 makes this equation true. So now let's look at the second example here, and notice that this one is slightly different. So this one contains parentheses right here. It still contains multiplication, it still contains addition, but these parentheses are going to change up the problem just a little bit. So again, I'm going to start by referring to my order of operations, my PEMDAS. And if I take a look at this situation, what I notice is that I have a parenthesis in this problem. And what this parenthesis in this problem tells me is that anything inside of the parentheses is going to come first in my order of operations. So here when I'm listing my order of operations, this time I'm going to list the +7 first because it's inside the parentheses. So I list out my order of operations and I write +7 because it's coming first because it's inside the parentheses. And then I'm going to do the multiplication of 5. So as I solve this equation, remember, I've listed out my order of operations so that I can undo them in reverse. So I'm going to start here with a multiplication of 5. In order to undo a multiplication of 5, I need to divide both sides by 5. So here I divide by 5, divide by 5, and I'm left with x plus 7 is equal to 35 divided by 5 is 7. And then from here I notice, okay, I've undone this step, so I move up one, and I need to undo a +7. Well, to undo a +7, I'm going to subtract 7 from each side. Well, 7 minus 7 is 0, so I have x over here. 7 minus 7 over here is 0. So I have found that in order to make the equation above true, x would have to be 0. So now let's try a new example here. So what I notice is I see 9 times x, so I see a multiplication in here. And then I also notice I'm going to use keep change here, so I have plus a -5. So in order to solve this equation, I need to list out my order of operations and undo them in reverse. Now, if I refer to my PEMDAS here, I don't have any parentheses, I don't have any exponents, so my multiplication and division are what are going to come first. And here, my multiplication of 9 would be first in the order of operations, followed by, I'm going to write adding a -5, and we'll talk about how to undo that in just a second. So we multiply by 9, and then we add that -5. So let's rewrite our equation here. We have 9x plus -5 is equal to 22. And now I'm going to undo my order of operations in reverse. So in order to undo a plus -5, remember plus -5 is really the same thing as subtracting 5. Those are the exact same thing. So in order to undo that -5, I need to add 5 to each side of this equation. So notice as I do this, when I add 5, -5 plus 5 becomes 0, so I'm left with 9x on the left-hand side of my equation. And then when I add 5 to the right-hand side, I end up with 27. So I've undone my order of operations in reverse by adding 5 to each side. Then I need to move up one step to the multiplication of 9. And to undo a multiplication of 9, I need to divide both sides by 9. So here I divide by 9, divide by 9. Well, 9 divided by 9 is 1, so I have x left on the right. 27 divided by 9 is 3. So I've found that when x equals 3, this equation here becomes true. So looking at example 4 here again, I notice that I have multiplication as an operation in here, and then I'm going to switch that to keep change. So I'm noticing that I have multiplication and addition. And if I refer to my order of operations, I have parentheses that need to come first, and I see parentheses in my problem right here. So because this problem contains parentheses, when we list our order of operations, that plus -2 is first because it's inside of parentheses, followed second by the multiplication of 3. And we're going to undo the order of operations in reverse. So let's start down here by undoing that multiplication of 3 first. In order to do that, we need to divide both sides by 3. So divide by 3, divide by 3. Then the left-hand side is left with x plus negative 2 is equal to 15. And then to undo a plus a negative 2, remember that's simply a subtraction of 2. So we're going to add 2 to each side. Noticing that as we do so, negative 2 plus 2 becomes 0. So we have x is equal to 5 plus 2 is 7. So we have our 1x value that when we put it back into this equation, makes that equation true. All right, let's do one more example together here. So if I look carefully, I notice I need to utilize keep, change, change. So I'm going to do plus negative 8. And then I need to look for which operations are contained in this problem. Well, I see a multiplication of 8 here times x, and I see an addition here. So I see two operations, multiplication and addition. Because I do not have any parentheses, my parentheses and exponents aren't useful with the order of operations. I'm just looking at multiplication, division, and then addition, subtraction. So what I notice is that in my order of operations, the first one will be a multiplication of negative 8. Then followed by, this is a positive 5, so it's an addition of 5. So order of operations tells me that multiplication comes first, followed by an addition of 5. And then when we solve an equation, we undo that in reverse. So if we write this down, so we have 5 plus negative 8x is equal to 53. The first thing we need to do is we need to undo that addition of 5. Well, we can undo an addition of 5 by subtracting 5 from each side. So if we subtract 5, we end up with negative 8x is equal to 48. Then we move one step up. We need to undo the multiplication of negative 8, and we do so by dividing both sides by negative 8. So we divide by negative 8, divide by negative 8. Negative 8 divided by negative 8 is just a 1x. 48 divided by negative 8 is a negative 6. So here I have found my one answer for x that if I take it and put it back into this equation up here, it will make the equation true.